Albert Einstein, one of the most brilliant minds in history, made significant contributions to science, philosophy, and humanity. However, like all humans, he was not infallible. Here are some notable mistakes and controversies associated with him. 1. Rejection of quantum mechanics. Einstein famously resisted some implications of quantum mechanics, a field he helped pioneer. His statement, "God does not play dice," reflected his discomfort with the probabilistic nature of quantum theory. He spent much of his later career attempting to disprove or reconcile quantum mechanics with classical physics, while the theory continued to be validated experimentally.
Born received his Nobel Prize in 1954, 1 year before Einstein's death. But in the decades in between, Einstein had become a vocal critic of this probabilistic picture of nature, convinced as he was that it could not be the way that the universe actually worked. Whilst Einstein and Born were friends, they never saw eye to eye on reality. Einstein was horrified by probability sitting at the heart of our world. He felt that the universe must be deterministic at its heart. Though he accepted that quantum mechanics could be probabilistic, he believed that there was something deeper, something hidden beneath the quantum world that clung to determinism. Indeed, in a now iconic letter to Born, Einstein outlined his sentiment. "I, at any rate, am convinced that God is not playing at dice."
2. The cosmological constant. In his equations of general relativity, Einstein introduced the cosmological constant to maintain the idea of a static universe, which was the prevailing belief at the time. When it was later discovered that the universe is expanding, Einstein reportedly called this his greatest blunder. Ironically, the cosmological constant was later revived in modern cosmology to explain dark energy, demonstrating its relevance in a different context.
In 1915, Albert Einstein published a very important equation. No, not that one. The one he published didn't just relate mass and energy, but mass, energy, and gravity. This equation replaced the older Newton's law of gravitation, which you may be familiar with, and it remains to this day our best description of how gravity works. Just like how F equals ma is a mathematical description of how the acceleration of an object depends on the forces applied to it, the Einstein equation of general relativity relates the motion of mass and energy, the t on the right, to the curvature of spacetime, the r's on the left. And Einstein didn't just pull this equation out of thin air. It was the natural consequence of a long and careful consideration of key principles of physics, combined with the advanced mathematics of curved surfaces, and of course, agreement with the experimental observations of the day. The equation, however, is deceptively simple. This one single line is in fact an incredibly fancy shorthand for what's actually a system of 10 second-order partial differential equations relating mass and energy to the curvature of spacetime, and the r's themselves are also a shorthand. But the point is this. After figuring out that these equations matched up with Newton's law of gravitation for weak gravitational fields, and after showing that the equations correctly predicted a previously unexplained anomaly in the orbit of Mercury, Einstein tried to figure out what the equations had to say about the universe as a whole. Of course, all the matter and energy in the universe is much too complicated to put into the equations and have any hope of solving them. But if you zoom out enough, you can approximate the universe as having a roughly constant density everywhere, and in every direction. And Einstein was able to solve the equations for a very simplified universe with constant density everywhere. The 10 complicated equations reduced to just 2 simple ones. This one says that the curvature of space in the universe is proportional to the density, so more stuff in the universe means more curvature of space. And this one says that the density has to be 0, which would mean there can't be anything in the universe. Needless to say, this was a problem. And it turns out that there are 2 solutions to the problem. The one Einstein took, and the one he didn't. Einstein's solution was this. He knew, since he had dived deep into the math, that it was possible to slightly change his original equations. You can just add on a very simple term without violating any key principles of physics. There wasn't much other motivation for adding this term, but it doesn't change anything about how well the equations match up with Newton's law when gravity is weak, or how well they predict the orbit of Mercury, or whatever. So maybe it was okay? And crucially for Einstein, the new term changes the equation for the density of the universe. Instead of saying density equals 0, it now says density is proportional to the new term. So if the new term was non-zero, that meant the universe could have stuff in it. Voila, solution number 1. The other solution to how the universe can have stuff in it was this. Don't assume, as Einstein had, that the universe is static and unchanging. The general understanding at the time was that the universe didn't expand or contract, and Einstein had also made a small but unfortunate technical error in his calculations which appeared to prohibit the possibility of a changing universe. So it's not surprising that Einstein didn't see this solution. But it was there. If you don't make the mathematical assumption that the universe is static, and you don't make the technical error Einstein did, you can find a different valid solution to Einstein's equations, which physicist Alexander Friedmann did. Actually, he used the version of the equations with the new term, knowing he could always set that term to 0 if it wasn't real. But the key part is, he didn't assume the universe was static. Friedmann found that the 10 equations again reduced to 2. The first equation now describes how the change in density of the universe relates to its change in size. Specifically, it says that if the universe gets bigger, then it gets less dense, which makes sense, stuff's literally spreading out. The second equation says that the deceleration of the universe is proportional to its density, minus Einstein's constant. In other words, the stuff in the universe attracts itself gravitationally, so the universe would have a tendency to pull inwards on itself, slowing any expansion and possibly even contracting. Unless Einstein's constant were real and had a value big enough to balance or overpower the gravitational attraction. So that's the solution Einstein didn't see. Later, once astronomers took sufficiently detailed measurements, it turned out that the universe was indeed expanding, so Einstein's equations didn't appear to have any need for the extra term he had added. Einstein was reported by physicist George Gamow to have called it his biggest blunder. And while there's no known documentation that he ever actually said or wrote those words specifically, there's plenty of record of him expressing disdain in other ways. Away with the cosmological term. I always had a bad conscience. I found it very ugly. Such a constant appears unjustified. And during Einstein's lifetime, that was certainly true. The term did appear unjustified. However, remember how Friedmann's equations predicted that the universe should be attracting itself gravitationally and so the expansion should be slowing down unless Einstein's constant is real? Well, in 1998, decades after Einstein's death, astronomers made the surprising discovery that the universe's rate of expansion isn't constant, and it isn't slowing down. It's getting faster. And so, in a great ironic twist, Einstein's constant does ultimately have a role in describing the universe, though it turns out to be a very different universe from what he'd imagined.
3. Neglect of family. Einstein's personal life was tumultuous, particularly his relationships with his first wife, Mileva Mari, and their children. His marriage to Mileva deteriorated due to his demanding nature and lack of emotional support. He even drafted a contract outlining strict terms for their relationship. Einstein's relationship with his sons was strained, particularly with Hans Albert, who felt neglected by his father's focus on work.
Einstein's relationship with his first wife, Mileva Mari, started out like the kind of love story that gets turned into a glossy Hollywood biopic. They met in college, where she was the only female physics student, fell in love, and had a family. All good so far, but in 1912, Einstein began an affair with his cousin Elsa. He was cruel about Marich in letters, describing her as, quote, an employee whom I cannot fire. In July 1914, Einstein wrote a list of demands for Marich, including doing his laundry, cooking his meals, and expecting, quote, no affection from me. They separated that year, and Marich had a breakdown. Einstein and Elsa married in 1919, the year his theory of general relativity was published. Einstein continued to have affairs throughout his second marriage. Marich's relationship with Einstein also cost her her own promising career in physics. After they married, it was expected that she would focus her attention on being a housewife and mother, and she was forced to drop her research. Though some scholars believe she was heavily involved in Einstein's work behind the scenes, even though her husband took all the credit.
4. Failure to support women in science despite his own first wife, Mileva Mari, being a talented physicist. Einstein did not significantly acknowledge or credit her contributions to his early work. While some historians debate the extent of her involvement in his research, others argue that her intellectual partnership was undervalued.
Every time someone mentions Einstein's contributions to science, I can't help but think about his equally brilliant wife, Mileva. Mileva was born and educated in Serbia. She was born in 1875. There she received a waiver from the Ministry of Education, which allowed her to attend physics lectures that were reserved for boys only. Mileva and Albert met at the Polytechnic Institute of Zurich. They quickly became inseparable. They spent endless hours studying together, and Albert even remarked in letters to her that when she wasn't there, he had an incredibly hard time focusing on schoolwork. By the time they graduated in 1900, the two had pretty much equal grades. Except for applied physics, where she got a top grade of 5 and Albert only a 1. Despite her hard work and commitment, Mileva never did receive her degree. Why? because the professor that provided the final examination decided that all 4 male students would get top marks, but not her. She wouldn't pass. They then both started their thesis work. In December of that year, they submitted their first article. Unfortunately, it only had Albert's name on it. At the time, a publication co-signed by a woman would have been frowned upon. The pair equally agreed to advance Albert's career over hers. His letters to her of the time even show that they collaborated together on the theory of relativity. So, around this time, lo and behold, she ends up getting pregnant. Now, Albert didn't want to marry her because he didn't have a job yet. So what did Mileva do? She went back to that professor and said, I want to take the oral examination again. And she did. And you know what happened this time? He failed her again. Now, Albert finally found a job. They got married in 1903. The two of them worked together into the night on scientific experiments and writing articles. They were known to sit together by the light of the kerosene lantern and work out physics problems. In 1905, Mileva reportedly said, we have completed scientific research that will make my husband's name known around the world. Albert even remarked at a party, I need my wife. She helps me solve all of my mathematical problems. By 1909, Albert was a highly regarded physicist, but his wife was still assisting him, and many of his lecture notes were even in her handwriting. Their relationship fell apart due to Albert's infidelity. She is quoted at the time saying, what is there to say about notoriety? One gets the pearl, one gets the shell. They divorced, and Mileva spent much of her time managing her son's schizophrenia. He was in and out of sanatoriums. It's proven that they collaborated from their school days all the way up through 1914. Mileva was quiet and she cared little for notoriety. So no one knows exactly what her contributions were. And we'll never know due to restrictions on women at the time. I make sure to do a little mental nod to her every time someone mentions Albert Einstein.
5. Underestimating the atomic bomb's consequences. Einstein's letter to President Franklin D. Roosevelt in 1939, co-written with physicist Le Sard, encouraged the U.S. to develop nuclear weapons in response to fears that Nazi Germany was doing the same. While Einstein did not work directly on the Manhattan Project, his equation was foundational to nuclear energy. After the bombings of Hiroshima and Nagasaki, Einstein expressed deep regret, saying, had I known that the Germans would not succeed in producing an atomic bomb, I would have never lifted a finger.
The armament race between the USA and USSR, originally supposed to be a preventive measure, assumes hysterical character. On both sides, the means to mass destruction are perfected with feverish haste behind the respective walls of secrecy. The hydrogen bomb appears on the public horizon as a probably attainable goal. Its accelerated development has been solicited. If successful, radioactive poisoning of the atmosphere and hence annihilation of any life on Earth has been brought within the range of technical possibilities. The ghost-like character of this development lies in its apparently compulsory trend. Every step appears as the unavoidable consequence of the preceding one. In the end, there beacons more and more clearly general annihilation. Is there any way out of this impasse created by man himself? All of us, and particularly those who are responsible for the attitude of the US and the USSR, should realize that we may have vanquished an external enemy, but have been incapable of getting rid of the mentality created by war. It is to achieve peace as long as every single action is taken with a possible future conflict in view. The leading point of view of all political action should therefore be, what can we do to bring about a peaceful coexistence and even a loyal cooperation of the nations? The first problem is to do away with mutual fear and distrust. Solemn renunciation of violence, not only with respect to means of mass destruction, is undoubtedly necessary. In the last analysis, every kind of peaceful cooperation among men is primarily based on mutual trust, and only secondly on institutions like courts of justice and police. This holds for nations as well as for individuals, and the basis of trust is loyal give and take.
6. Overlooked contributions of others. Einstein's rise to fame often overshadowed the contributions of other scientists who worked on similar theories. For example, David Hilbert developed equations for general relativity independently and concurrently with Einstein, but Einstein received most of it. 7. Skepticism toward black holes. Einstein initially doubted the existence of black holes, despite his own equations predicting them. He dismissed the idea of gravitational collapse as a physical reality, even though later discoveries, such as those by Carl Schwarzschild, confirmed their existence. 8. Political naivety. While Einstein was outspoken about his pacifist and humanitarian ideals, his political actions sometimes conflicted with his principles. He initially supported Zionism as a cultural movement, but later expressed concerns about the establishment of a Jewish state, fearing it could lead to conflict. His political activism, while well-meaning, occasionally lacked practicality or foresight. 9. Misjudgment of teaching. Einstein's teaching methods were sometimes criticized as unengaging or overly abstract. While he was a brilliant thinker, he was not always an effective communicator in classroom settings, which frustrated some of his students. 10. Resistance to technological focus. Einstein believed that humanity's moral development lagged behind its technological advancements, leading to potential misuse of scientific discoveries. While his concern was valid, some critics argued that his pessimism sometimes hindered his ability to fully embrace new technological possibilities. Albert Einstein's mistakes and missteps reflect his humanity, showcasing that even the most brilliant individuals face challenges and make errors. His willingness to reflect on these moments and express regret where necessary adds depth to his legacy, reminding us that growth and learning are lifelong processes.
Einstein got divorced. Did you people know that? No, I didn't either. Albert Einstein, one of the greatest geniuses of all times, got divorced. They should tell you that before you get married. It shouldn't be, do you love her? Do you want to spend the rest of your life with her? It should be, do you think you're smarter than Einstein?